Welcome to Day 2 of the IoT Boot Camp organized by Mitov Software and Embarcadero. My name is Bojan Mitov, the president of Mitov Software, and today I will demonstrate you how to connect to Arduino from Delphi. There are many ways to communicate with Arduino. Some of the most popular are simple serial communication, structured packet serial communication, communication over Ethernet or Wi-Fi, TCP or UDP, Bluetooth Classic, and Bluetooth LE. Now let's create some cool projects using some of those communications. For this project, we'll connect ultrasonic distance measurement sensor to our Arduino Nano. The sensor has 4 pins. We'll connect red wire to VCC power, black wire to ground, yellow wire to trigger, and green wire to echo. On the Nano side, we'll connect the black wire to one of the ground pins, the red wire to 5 volts, the yellow wire to digital pin 2, and the green wire to digital pin 3. We will start with new Visuino project. Select board type as Nano. From the tool palette, select Ultrasonic Ranger and drop it on the form. Connect the output pin of pin trigger to digital pin 2. Connect the output pin of digital channel 3 to the input echo pin of the Ultrasonic Ranger. And connect the output of the Ultrasonic Ranger to the input of serial channel 0. Generate the Arduino code and open the Arduino IDE. Compile and upload the code. The project is uploaded. Now we can connect with serial terminal and we will see the distance measured by the Ultrasonic Ranger. And if we point it to big distance, it will measure it in centimeters. And we can display this on the scope. Every now and then we'll have some noise from the sensor missing the bounce signal, but we should be able to map the room and the surrounding by pointing it in different directions. This is a big distance to one of the corners of the room. And this is the signal bouncing off of me, actually. And now bouncing off the camera. Now we can create a Delphi application to receive the distance from the sensor. We will start by adding COM port. Double-click on it. Select the COM port of our Arduino and a terminal component. Set the terminal to align client so it will take the full form. Switch to the open wire view. Connect the output of the COM port to the input of the terminal. compile and run the application. You can see the data arriving from the ultrasonic ranger and changing as we place object in front of it or point it in different directions. For this project, we'll connect analog XY joystick to Arduino Nano. The joystick has VRX and VRY analog signals, and it also has a switch that can be activated by pressing the joystick handle down. We'll connect black wire to the ground pin of the joystick, red wire to the 5 volts, green wire to the VRX, yellow wire to the VRY, and purple wire to the switch. The black wire will be connected to one of the Arduino Nano ground pins here. The red wire will be connected to 5 volts. The green wire will be connected to analog pin 0, yellow wire to analog pin 1. The purple wire will be connected to digital pin 2. In this project, we'll use structured packet communication to send multiple channels of data from Arduino. We'll start by adding a packet component. Click on this Tools button, add 2 binary analog channels and 1 binary digital channel. Expand the head marker and add 5555 in the bytes editor. This will be our unique header to easily discover the beginning of the packets. Connect the output pin of the packet 1 to the input pin of serial channel 0. Connect the input pin of the first analog channel of packet 1 to the output pin of analog channel 0 on the Arduino board. Connect the output pin of analog channel 1 to the input pin of the second analog channel of the packet 1, and connect the input of the digital element on packet 1 to the output of digital pin 2. Since we'll be using a joystick that does not have pull-up resistor on the digital pin, we will use the built-in pull-up resistor on the Arduino Nano by enabling the isPullup property of digital channel 2. Generate the code, compile and upload the code. The code is uploaded. Now we can select packet 1 as format for our communication. The terminal will be disabled. The scope immediately will be populated with the 3 channels for the communication. An instrument wrap will appear with 2 gauges and LED to display the data from the channels. If we connect, we will see the data arriving from the joystick We can change it by moving the joystick, and we can switch on and off the switch. We can monitor the same on the gauges. And on the scope. When I created this project, I did not change the board from Uno to Nano. Since Uno and Nano have exactly the same capabilities and pins, and just differ by its size, this works perfectly fine. It is good practice, however, to change the board to the corresponding board, even when it is not necessary, to make sure there is no confusion. Now it's time to connect to Arduino from Delphi. We'll start with new VCL application. We'll add COM port component. Double-click on it and select the COM port of our Arduino. We'll add unpacked component. Scope component. Two angular gauges. And an LED. We'll set the max for the gauges to 1, since the values from the Arduino will be between 0 and 1. Switch to the open wire view. Double-click on the unpacked component. Add 2 floating point channels and 1 Boolean channel. Close the elements editor. Expand the head marker. Click on the period button for the bytes and enter 5555, the same as we did in Visuino. Close the bytes editor. Connect the output pin of the COM port to the input pin of the unpacked component. Add 2 more channels to the scope component. Connect the output pin of the first floating point channel to channel 0 of the scope and the first angular gauge. The output of the second floating point channel to channel 1 of the scope and the second gauge. The output of the Boolean channel to channel 2 of the scope and the input of the LED. Compile and run the application. We can use the joystick to change the data that arrives on the scope and the gauges, and by pressing it, we can turn on and off the LED. This also will be shown on the scope. For this project, I will connect a DHT11 temperature and humidity sensor to the Node MCU Mini from my IoT kit. We'll connect a red wire to the VCC pin of the DHT11, black wire to the ground pin, and blue wire to the data pin. The DHT11 uses a proprietary digital protocol to communicate with the microcontroller. On the node MCU, we'll connect the black wire to ground, the red wire to one of the 3.3 volt pins, and the blue wire to digital pin 3. You can see also the pins labeled on the top of the module. We will start with new Visuino project. Select the board as not MCU. The node MCU has Wi-Fi module. First, we need to specify the access point where we want the module to connect. Select Access Points and click on the period button. Add access point. Enter the name of the access point and the password. Close the access points dialog. Next, we need to specify the name of the module so we can discover it on the network. We will call it DHT11 server. The module is ready to connect to the network. Now we need to add server socket. Select Sockets and click on the period button. Then add a TCP/IP server socket. Set the port of the socket to 8080 and close the sockets dialog. To read data from the DHT11 module, we need to add Visuino component for it. The module is connected on digital pin 3, so we'll connect the sensor output pin of the component to the digital input pin of digital channel 3. To send both temperature and humidity to the socket, we can use a structure. Select Make Structure Component and drop it in the design area. Click on the Tools button and add 2 analog channels. Close the Elements Editor, connect the temperature to the first element and the humidity to the input pin of the second one. Connect the output of the make structure to the input of the socket. The project is ready, however, if we run it, it will send data very fast over the socket. We would like to send temperature and humidity data only once a second. For this, we can use a clock generator. We will connect the output of the clock generator to the clock input pin of make structure. This will specify that the structure is sent only once a second. Now we can generate the code and open the Arduino IDE. Select the board. In this case, Node MCU version 1.0. Select the port. In my case, COM port 8. Compile and upload the sketch. The code is uploading. The project is ready to test. Now we can connect to the Node MCU from Delphi. First, we'll add a socket component. We'll set the host to DHT11 server and dot at the end. Adding dot at the end is important because of the way the name is resolved on the network. For port, we'll enter 8080. We will add split structure component, scope component, thermometer, and analog gauge. We will switch to the OpenWire view. We will click on the Tools button of the split structure and add two float channels. Close the Elements editor. Connect the output of the client socket to the input pin of the structure. Add one more channel to the scope component. Connect the two channels to the two elements of the split structure, and the output of the first element to the thermometer, the output of the second element to the angular gauge. Now we can compile and run the application. You can see that the data starts arriving once a second. And if I warm up the sensor, the temperature will start changing and the humidity will increase from my finger. The DHT11 is not very sensitive sensor, but it is cheap and very affordable. So it is very often used for small test projects. You can see the data updating once a second. And if I move away my finger, the temperature will stop dropping and the humidity will return to normal. For this project, I will connect I2C organic LED display to the NOT MCU Mini from the kit. The display has 4 pins. We'll connect black wire to the ground pin, red wire to the VCC power, yellow wire to the SCL clock for the I2C, green wire to the SDA data for the I2C. On the NOT MCU side, we'll connect the black wire to one of the ground pins, red wire to one of the 3.3 volt pins, the yellow wire SCL to digital pin 1, clock for the I2C, and the green wire to digital pin 2, data for the I2C. We will start with new Visuino project. Select the board as NOT MCU. Expand modules, Wi-Fi, add access point, set the access point SSID and password, close the access points editor. In the modules Wi-Fi, set host name as OLED, add a server socket, set the socket port to 8080, Close the sockets editor. Now it's time to add components to control the organic LED display. Type OLED and select the I2C version. Drop it in the design area. Connect the output pin of the display to the input pin of the I2C channel. Connect the output pin of the server socket to the input pin of the display. Generate the Arduino code and open the Arduino IDE. Compile and upload the code. The code is uploaded and the Node MCU is ready. Now it's time to connect to the module from Delphi. We will start by adding a client socket component. Set the host as OLED dot. Remember to put the dot at the end, otherwise the module will not be discovered on the network. Set the port to 8080. Add a memo. Set the alignment to client to take the full form. Clear the lines so the memo will be clean at the beginning. Switch to events and create on key press event. In the event for the client socket, call send and pass the key. Compile and run the application. If we type anything in the memo, it will appear on our display. As you can see, the display is working as programmed. For this project, we'll connect a servo to the Node MCU Mini from the kit. The servo has 3 wires, orange, red and brown. The brown wire is ground and we'll extend it with male to female jumper wire of black color for the ground. The red wire is power and we'll extend it with red male to female jumper wire. The orange wire controls the servo and we extend it with orange wire. The servo is 5 volts and the Node MCU Mini has VIN pin that conveniently has 5 volts from the USB. We'll connect the red wire to this pin. We'll connect the black wire to the ground pin and we'll connect the orange wire to digital pin 3. We will start with new Visuino project. Select board type as Node MCU. Expand modules, Wi-Fi. Set the host name as servo. Add access point. Set SSID for the access point, in my case ACES, and password. Close the access points editor. Expand modules, Wi-Fi, and add a server socket. Set the port to 8080. Close the sockets editor. The data will arrive as integer value. We can use split structure to extract the value from the packet. Connect the output pin of the server socket to the input pin of split structure. Click on the Tools button and add integer channel. Close the elements editor. The integer value will be between 0 and 1000. We need to convert it to range of 0 to 1 for the servo. For this, we can divide it by 1000. Add divide by value component. Set the value to 1000. Connect the output of the integer element to the input of divide by value. Now we need to add component to control the servo. Connect the output pin of divide by value to the input pin of the servo control component. And connect the output of the servo component to the digital input pin of digital channel 3 where our servo is connected. Generate the Arduino code and open the Arduino IDE. Compile and upload the project. The code is uploaded and the module is ready. Now it's time to connect to the module from Delphi. We will start by adding client socket component. Set the host name as servo followed by dot. Make sure you add the dot at the end, otherwise the module will not be discovered on the network. Set the port number to 8080. To pack the data, we will use make structure. And we'll use a track bar to control the servo. Set the max property of the track bar to 1000. Select the position property and click on the button at front of the property name. Select integer source pin. This will add integer source pin to the position property using Visual Live Binding. Click on the OpenWire tab. Click on the Tools button of the Make structure and add integer channel. Connect the position pin of the track bar to the in pin of the integer element. Connect the out pin of the Make structure to the in pin of the socket. Compile and run the application. You can see that we can use the track bar to control the servo. We covered only a very small fraction of what is possible to achieve when programming Arduino boards with Visuino. Here are some additional resources: the main Visuino website, visuino.com, the Visuino wiki documentation, the instructables that I have created, the Hackster.io Visuino community, my YouTube channel, and my blog, where I often post updates and news about the Visuino and the lab packs development. Once again, my name is Bojan Mitov, the president of Mitov Software. Mitov Software offers a wide variety of products, including video processing library, audio processing library, digital signal processing library, computer vision library, data visualization library, visual instrumentation library, artificial intelligence library, Boolean logic library, universal animation library, serial and TCP communication library, universal visual live binding library, a free Delphi library called Mitov Runtime, OpenWire Studio, a graphical development environment for Windows, Visuino, graphical development environment for Arduino. We also support some open source libraries, including the OpenWire library and the iGDI Plus, a Delphi-friendly GDI Plus library. Thank you for attending the IoT Boot Camp and listening to my session.